Hello student, welcome to study at the UTKARSH classes. Now we discuss about the real number, the first chapter of class 10 mathematics. Then we discuss about the real numbers. Real number are are those which can be read and write. Read and write. We can say the real number are those numbers which can be read and write. We read about the numbers in the number system as even number, odd number, whole number, natural number, rational number, irrational number. These are all of the real numbers which can be read and write. Then we can say the real number are those numbers which can be read and write. Then we discuss about the Euclid division lemma. In this, we let two any positive integer as a and b, and which exist as a unique integer as q and r, where a is the dividend, b is divisor, and q is quotient, and r is known as remainder. Then the Euclid division lemma in the form of a equal to bq plus r. Then we can say dividend equal to divisor into quotient plus remainder, where r may be greater than equal to 0 and less than b, because the remainder never be equal to divisor. We know that the remainder never be equal or greater than to divisor. Clear? Now we discuss about the Euclid division algorithm. What is Euclid division algorithm? Euclid division algorithm is a method to evaluate the SCF any two positive integers. And we can say that it is the step-by-step method to evaluate the SCF any two positive integers. Clear? Let to understand the Euclid division algorithm, let some example as 80 and 200. Then we know 200 is greater than 80. Clear? Now we consider the 200 as A and 80 as B. We divide the 200 by 80. Then first step, we divide the 200 by 80. We know the 2 times is less than and 3 times of 80 is greater than, then we take it the lesser number or equal number. Then we multiply by 80 by 2, it gives 160. Then it gives the remainder as 40. Clear? Here r is 40. We repeat this method till remainder 0, where r is not equal to 0. Then we repeat this method. We consider 80 as a and the remainder as b. Then we consider 80 as a and 40 as b. As dividend, 80 is equal to 40, and then we 40 multiply by 2, which gives 80, and leaves remainder 0. Then the remainder is 0. The value of v is the HCF of the given number. Clear? Now we can see the HCF of 280 will be 40. Clear? Now we take another example as 45 and 120. Clear? Now we consider 120 as A and 45 as B. Now we use the Euclid division algorithm as A is equal to BQ plus R. Now we use the Euclid division algorithm. So we write 120 is equal to 45 multiplied by 2, which leaves the remainder 30. Clear? Because it is 90 plus 30 is equal to 120. Then if here is R is not equal to 0, then we again repeat this method. Then we consider 45 is equal to A and the remainder as B. Clear? We write it in form of Euclid division algorithm. Then 45 is equal to 30 and 1 time of 30 is equal to 30, which leaves the remainder 15. Clear? Here is R is also not equal to 0. Then we again repeat this method. 30 is equal to 15 into 2 plus 0. Then now the remainder is 0. Remainder is 0. Then we can say the HCF of the given integer is 15. Clear? So we can say the Euclid division algorithm is the step-by-step method to evaluate the HCF of any two integers. Clear? Now we discuss about the exercise 1.1, and the first one the question is why use the Euclid division algorithm to find the HCF of the given numbers as 135 and 225. Then since we know 225 is greater than 135. Now applying the Euclid division lemma to find the HCF of 225 and 135. Now we take 225 as A and 135 as B. By the Euclid division lemma, to get 225, we write it in the form of 225 is equal to 135. When we goes to 225 by using 135, we can say the 1 times of 135 gives 135, and which leaves the remainder 9. Here R is not equal to 0. Here R is not equal to 0. Then we repeat the step as 135 is equal to 90. 90 goes to 135 1 times and leaves the remainder 45. Here R is not equal to 0. Then we repeat this step again. Then 90 is equal to 45. When the 45 multiplied by 2, we get 90 and leaves the remainder 0. Here R is equal to 0. Then R is equal to 0, we can say the HCF of the given number as 135 and 225 is equal to the last divisor of the number. And where the procedure is stopped, then the last divisor is also known as the HCF of given integer. Clear?